All right, this is a video on common exponents, variable exponents, rational exponents, and roots. All right, this is by answer key. Normally I do this in class with students. I'm not sure if I do it right now or a little bit later, but either way, it's okay to do it now. When we think of squares, a square is an actual four-sided figure, quadrilateral, whose sides are all equal to each other. And when we find the area of this square, it's going to be one of these numbers, dependent upon what the side lengths of the sides are. In other words, if this was 5, this would also have to be 5. And so the area here would be 25 square units. And that's why 25 is what we call a square. Of course, 36 would be a 6 by 6 square. 121 would be an 11 by 11, and so on. Same thing with the cubes. You can think of the cube as a three-dimensional object. Okay, and the cube is going to have, a length of, say, 2, width of 2, and this depth there, length times width times height, is, they're all 2s if it's a perfect cube. And so to find the volume of this, you would multiply 2 times 2 times 2, and you would get 8. Okay, and so a cube of 64, well, that would be a 4 by 4 by 4 cube, and so on. Okay, fourth powers, well, there's no 4 dimensions, but think of it in terms of multiplying this thing by itself 3 times for a cube, 2 times for a square, 4 times for a fourth power. 3 times 3 times 3 times 3 is 81. Okay, and so it's beneficial sometimes to know some of these common squares and cubes and fourth and fifth powers that show up. Now, with the variables, if it is a square, any variable to any even power is a square. Folks, if I think of x to the 10th, that's an x to the 5th by x to the 5th. You see, that's a square, x to the 5th by x to the 5th, because when I multiply them to find the area, multiply same base, you add exponents. Okay, so x to the 10th is a square. X to any even power is a square. Cubes, look, as long as the exponent is divisible by 3, it's a cube. And so you're going to see that some squares are cubes as well with these variable exponents. Okay, variable fourth powers. Any exponent divisible by 4 is a perfect fourth power. And I'm drawing these lines to show you, like x to the power 32. 32 is divisible by 4 8 times. So guess what? The fourth root of x to the 32nd power is x to the power 8. You take the power and you divide it by the root. And that's how you're going to simplify it. I mean, you could write, the fourth root of x to the 4, 8, 12, 16, 20, 24, 28, 32. Okay? And how many x to the 4ths do I have in here? 1, 2, 3, 4, 5, 6, 7, 8. There it is. Bam. X to the 8th. Okay. Variables that are perfect fifth powers. Well, as long as the exponent is divisible by 5, it's a perfect fifth power. That's why sometimes when you have like the fifth root of x to the 17th power, could be rewritten as the fifth root of x to the 15th times x squared. There's my 17. And I can simplify this quite easily by saying, 15 divided by 5 is 3. and the x squared stays in. Okay, now this might help some of you that are on that higher order thinking, to make this a little bit easier for you to do those other kinds of problems that we had. Later on in this course, we are going to talk about fractional exponents, okay? And again, as long as you remember that it's power over root, the rational exponents are not that difficult. So when you see a 2 in the bottom, that's really square root incognito. This is cube root, right? Cube root, fourth root, and then of course fifth root. Okay, not quite sure why these little question mark things are here, but when I have something like, I think that's supposed to be an equal sign, actually. X to the 1/2 power is equal to the square root of x, and it is x to the power 1. But since we do not write a 1 as a power on x, it seems silly to write it that way. So we know x to the 1/2 power is simply the square root of x. X to the 1/3 power is the cube root of x. X to the 1/4 power is the fourth root of x. Now, if you have something like x to the 2/3 power, well, that is power over root. Root is 3. Power is 2. That's a cube root of x squared. All right, I didn't want to take too much time talking about this because I'm sure I will revisit this again at some point. But I just wanted to impress upon you that it's important that you do know your squares, that you do know what a square is, what a cube is, and talking about variable squares, cubes, fourth powers, and fifth powers. Again, any variable to an even power is a square. Any variable to an exponent that is divisible by 3, say 27, that is a perfect cube, because 27 divided by 3 is 9. Okay. Of course, if that was the fourth root of x to the 27th, all bets are off because 27 is not divisible by 4. If you have any questions, let me know.